Welcome you all to the new session of computer graphics. Today we are going to learn about coordinate systems. In coordinate systems there are 4 different types of coordinates. They are modeling coordinates, world coordinates, normalized view coordinates and device coordinates. We will be learning each of them in detail. So let us move on to the first one, modeling coordinates. Suppose we wish to take a photograph. To capture an image, we have to identify all those objects that are to be included in a scene. So, identifying objects for a scene to be captured. I have already decided to capture an image. So I have to decide what objects I am going to capture. So here I have selected 2 objects. One is a cylindrical object and another is a cubical object. So I am going to take a photograph of both these objects. So the process of identifying objects is included in modeling coordinates. Clear? Now comes the world coordinates. After identifying objects, I have to place them in a particular position. So here I placed the cube in front side and placed the cylindrical object just behind the cube. So determining the positions of the object is one thing. Second thing, I have to identify the direction from which I am going to take the photograph. Whether I am going to take the photograph from the front side, or I am going to take from the top, or I am going to take the photograph from the side. So the direction of the viewing is to be determined and the positions of the object is also to be specified. These 2 things are specified in world coordinates. What are they? One is the positions of the object, next the viewing direction. All these things are specified in world coordinates. Okay, now before moving on to normalized view coordinates, I am going to explain the device coordinates. So this is device coordinate. Clear? See, once I have identified objects and I have already specified the viewing direction and the positions of the object, I have taken my camera and going to capture the image. I took the photograph. After taking the photograph, the image from the real scene will be transferred to the screen of the mobile. If I am using a mobile, then the real life object will be transferred to the screen of the mobile. If I am using a camera, then from the real life the objects will be transferred to the screen of the camera. So whatever may be the device used for taking photograph, if the image is transferred to the screen of the device which is used for taking photograph, the final image displayed on the display screen is called device coordinates. Clear? So now you know what is a modeling coordinate, what is a world coordinate, and from the world coordinate, when you take a photograph, the image is transferred to the screen of the display device which is called device coordinates. Now let me tell you what is this normalized view coordinates. See, you might have observed that the real life size of the objects is very large. The cylindrical object may be very large, the cubical object will be very large, but when the image is captured using a camera or a mobile, depending on the size of the frame or the screen size of the display device, the object size also reduces. You might have seen that. You may take the photograph of your friends. The size of your friend may be very large, but when you take the photograph and see or watch it through your mobile phones or through your camera, in the frame when the picture is displayed, the size of the entire scene will be very small. So depending on the screen size, the real life object's size will be reduced. And if you are seeing the object on a very large projector screen, so what happens? The real life object was large, and when you see the same object on a very large projector screen, the size of the object enlarges. So depending on the size of the screen of display device, the image can either be enlarged or the image can be reduced. To adjust this change in size, we are using normalized view coordinates. So what is the purpose of this normalized view coordinates? Once you have decided to take a picture, before transferring it to the device, normalized view coordinates reduces the size of the picture to very small. What did I say? Before you transfer the actual image from the real life to the device screen, normalized view coordinates reduces the size of the picture to very small, and the final size of the picture is a unit cube. In the unit cube, we are having 3 dimensions, an x dimension, y dimension and z dimension. Every dimension will be represented in the range 0 to 1. That means x will be represented in the range 0 to 1. That is, minimum value of x is 0 and maximum value of x is 1. Similarly, the y dimension will also be represented in the range 0 to 1, and the z dimension will also be represented in the range 0 to 1. That means the actual size of the objects or the scene will be reduced. The picture is reduced to a very small size, that is a size of a small unit cube. Once this is done, depending on the size of the screen, whether it is smaller or larger, from the unit cube the size of the image will be enlarged. Clear? So if it is a mobile screen, the size will be enlarged to a perfect to a specific order. If you are viewing the image on a laptop, then the image size will be enlarged to a much larger version. So depending on the size of the screen, the image can either be enlarged or not. Clear? So in this way, modeling coordinates are used to identify the objects. World coordinates helps you to determine the positions of the object, and it helps you to identify the viewing direction. And using normalized view coordinates, the actual image will be reduced to a very small size. Then depending on the size of the screen, the unit cube is enlarged to fit the screen size. So these are the 4 different types of coordinates which come under coordinate system. Clear? Now let us move on to next topic. Now we are going to learn about color codes and grayscale. These are the 2 terms which we are going to learn, color codes and grayscale. Let me explain what are these. See, I am going to talk about a black and white screen where only 2 basic colors are there. I can either display using a black color or a white color, or I can use a combinations of both these colors to get gray shades. Clear? So we are talking about black and white systems. Now to represent various colors, there are different colors, black, white and gray shades. To represent these colors, I had to use some bit combinations. So let us see how we can obtain this. If I am having only one bit, with a single bit I can represent only 2 colors. How? If I am having only one bit, that bit can either be 0 or 1. If it is 0, it represents a black color. If it is a 1, it represents a white color. So with only one bit I can have 2 possible colors. So to increase the color shades, what I have to do? I have to increase the number of bits. That means if I am having more than one bit, suppose I am having 2 bits, then how many colors do I have? Let us check. With 2 bits I can have combinations like 0 0, 0 1, 1 0 and 1 1. That means with 2 bits I can have 4 combinations. So how to calculate given the number of bits, how can you obtain the number of combinations? See, this is the equation. If I am having n bits, then with n bits I can have 2 raised to n combinations or 2 raised to n colors. Let us check. If n is 1, then 2 raised to 1, 2 colors can be obtained. Correct. If n is 2, then 2 raised to 2 colors can be obtained. 2 raised to 2 is 4. Clear? So If n bits are there, using n bits you can create 2 raised to n different colors. Okay, so using that pattern, here I am using 2 bits. With 2 bits I can have 4 different colors, and let these colors be black, dark grey, light grey and white. If both the bits are 0, it represents a black color, and if both the bits are 1, it represents a white color. What happens if only one bit is 1 and the other bit is 0? It represents a dark grey or a light grey. So every combination of color can either be represented using the color name, or I can represent it using a color code. This is the code given to this bit combination. So I can either say color code 0 is having a bit combination of 0 0, or I can say the color black is having a bit combination of 0 0. So every color is identified either using the name of the color or using the color code. So from this it is clear, when you increase the number of bits, with increasing bits you can have multiple colors. So in a black and white system, depending on how many bits you have, you can have varieties of gray shades, because only 2 primary colors are there, black and white. You are having only 2 colors, black and white. So with increased number of bits you will be getting different shades of gray colors. Other than these colors you won't be getting any other colors, since it is a black and white system. Now what about a color system? In color system we are having 3 primary colors, red, green and blue. So in this world any color can be obtained by combining these 3 colors, and hence these 3 colors, red, green and blue, are known as primary colors. So in a color system, if I want to display images with many colors, I have to increase the number of bits. Let us see how we can do that. If I am using 3 bits, that means 1 bit to represent red color, 1 bit to represent green color and 1 bit to represent the blue color. Altogether I am having 3 bits. With 3 bits I can have 2 raised to 3, that is 8 different colors. They can be represented as 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 111. So these are the 8 possible combinations you can obtain using just 3 bits. So 3 bits are used, 1 for each primary color. Using 3 bits I got 8 different combinations, and when all the 3 bits are 0, it corresponds to a black color. When all 3 bits are 1, it corresponds to a white color. Otherwise each combination of bit corresponds to separate wide ranges of colors like blue, green, cyan, red, magenta and yellow. So here also every color combination can be identified either using a color name or using a color code. Now using just 3 bits I can have only 8 colors. What if I want more colors? Simple, just increase the number of bits. How? Here I have used only 1 bit to represent red, and 1 bit for green, 1 bit for blue. I can increase the number of bits. Let us have 2 bits for red color, 2 bits for green color and 2 bits for blue color. 2 plus 2 plus 2. Altogether I am having 6 bits now. Clear? 2 bits for red, 2 bits for green, 2 bits for blue. So altogether I am having 6 bits. With 6 bits I can have 2 raised to 6, which is 64. With just 6 bits I can represent 64 different colors. So in this way, just by increasing the number of bits we can have multiple colors, so that we can have a display on the screen. So in a black and white screen we can have only black color or white color or different shades of gray color depending on the number of bits. Similarly, in a color display we are having just 3 primary colors, but using just 3 primary colors and with multiple bits. we can create lots of colors. So in this way, color display monitors can display various colors, and black and white monitors can also display various colors in gray shades. Okay, now we are going to learn two new concepts like bitmap and fixmap. Let us understand what is the difference between bitmap and fixmap. So this is a typical frame buffer, and this is the corresponding screen. So here, depending on what value is stored in the frame buffer, the corresponding pixel on the screen will either be highlighted or not. Since here a 0 is represented, this pixel will not be highlighted, and since a 1 is represented in this pixel, the corresponding pixel will be highlighted. The concept is already discussed. So let us see what a bitmap is. We are going to talk about a black and white monitor which can display only black and white colors. So here I am having only two colors. One is a black color, another one is a white color. So black color is represented using the bit 0, white color is represented using the bit 1. Okay, so in the frame buffer I am using only one bit to represent a color. That is, here the first pixel is not to be highlighted, and I am using only one bit to represent the color of the pixel. That means for representing the color in a pixel, if I am using just a single bit, it is called a bitmap. One bit is used to represent the color of the pixel. It is called a bitmap. If a 0 is represented, the pixel will not be plotted and black color remains at that pixel. If you find a 1 in the frame buffer, it indicates pixel is to be plotted and a white color will be plotted in the pixel. So this is how bitmap works. Now comes the fixmap. Here also we have to consider a frame buffer and a screen. But now we are going to talk about color display monitors. In a color display monitors, we can display varieties of colors. So to have multiple colors, we have to use multiple bits. Clear? To use multiple colors, we have to use multiple bits. See, if to represent the color of a single pixel, let this be a pixel. To represent the color of a single pixel, I have to use multiple bits. See, multiple bits are used to represent the color of each pixel. Each pixel color is determined by multiple bits like this. Let this be the first cell in the frame buffer like this. Here in this frame buffer I used only one bit, but here in the frame buffer I am using more than one bits. So here I have used 0, 1, 0. 0, 1, 0 is the color combination of green color. So the first pixel will be displayed using green color. Now this is the second position. In the second position I have used the color combination 101. 101 is the color of magenta. This pixel in the frame buffer, it stores the bit value 110, and it is the color of a color combination of yellow. Here I have used the value 011, which is the color combination of cyan. So in this way, to display color in each pixel of the screen, if more than one bits are used to represent the color, it is called a fixmap. So in black and white systems, only one bit is used to represent the color of the pixel, one pixel, and it is called a bitmap. And in color monitors, to represent the color of a single pixel, multiple bits are used, and it is called a fixmap. So this is the difference between bitmap and fixmap. Hope all the concepts are clear to you. Thank you.